Exercise 11G question 2b. So we want to integrate this fraction, and this is basically integration by partial fractions, since we have a fraction that has lots of algebraic terms, and I think this is very clear that it's partial fractions. Now, in order to write this as partial fractions, we need to remember that partial fractions only work when we have a proper fraction, but this is an improper fraction because the numerator has a higher power than the denominator. So we first need to use long division to find the polynomial part of basically the answer to the division, which is going to be the polynomial part plus the basically the partial fraction part of that. So that's what we need to do here. So first of all, you're going to use the long division in this case. So we divide the entire of the numerator by x squared plus x, which is the denominator. So first of all, if we have x, so x times x squared is x cubed plus x, times x is x squared. So we subtract and we get 0 and x squared plus 2. Now at this point, we also can't go further. Well, actually, here we need to continue, because if you have 1, then it becomes basically x squared plus x, and then when we subtract, then we'll get 2 minus x, and this is the point that we obviously stop, because now we can't continue any further. So now that we have written this in this form, then that means we are essentially going to have so the fraction is x cubed plus 2x squared plus 2, and denominator is just x times x plus 1, is basically equivalent to the quotient, or just the answer to the division, which is just the polynomial part of the partial fraction, but I mean the polynomial part of the expression. And then the actual partial fraction is for this part, because here we write down the remainder, and then here is just basically the divisor. So in this case, x times x plus 1. So essentially this number here on the denominator. So we always have the remainder here, and then here is the divisor. Okay, at this point, again, we want to convert the second fraction. So this one, 2 minus x, into a partial fraction, so x times x plus 1. So we can rewrite this in the form a over x plus b over x plus 1. Now the thing is, we obviously need to include everything in a single fraction. So this was just a way just to show you that we want to replace this by a over x plus b over x plus 1, and then this big basically collection of expressions is what we use to find partial fractions, essentially. So now we multiply every single term by the denominator, x times x plus 1, and that gives us x cubed plus 2x squared plus 2. And now on the right hand side, it's x plus 1 times x plus 1 again, plus a times x plus 1 plus b times x. And now it's the substitution part. So if we set x is equal to 0, then we'll have 2 is equal to a, essentially. So that's very easy, because we'll have lots of cancellations. And when x is equal to minus 1, then in this case, we get 3 on the left hand side, and on the right hand side, we'll just simply, because this one is going to be 0, so we'll just have minus b, and b is equal to minus 3. Now the integration becomes basically x plus 1 plus 2 over x minus 3 over x plus 1 dx, and it's a very simple integration. So because the first term integrates to x squared over 2, the second term integrates to x. Now here is 2 ln x basically, and then here's minus 3 ln mod x plus 1 plus c, and that's it basically.